All right, so just a video for the activity match pairs confidence intervals. So this one actually represents an experiment that I did. Right? So these are the outcomes. The right versus left dot test. Online activity designed to measure manual dexterity and hand-eye coordination. Participants click as many moving dots as possible within a set time frame, usually about 10 seconds. Using either their left or right hand. The goal is to determine which hand is faster and more precise in completing the task. The score is the number of dots clicked during the 10-second time limit. Scores are listed below. You can click on the website and have a look and see what that's all about. Right? So it's really just a matter of, if you wanted to collect your own data, just start the game and click any dot that shows up. You get the idea, hopefully. I'm doing it with my right hand. When I actually collected my data, I didn't do it with a laptop and a mouse. I did it with an iPad. So it made it a little easier to do it lefty, because doing it righty is not that much of a problem, but doing it lefty was just kind of I don't want to say a nightmare, but it was definitely challenging. Right, so that's an example of gameplay. Right, so you can do that if you want. Play around with that. We will be using similar activities to that online applet, and as we go forward. So so you'll get an opportunity to play around with that. But for now, I just want to walk you through how to do a confidence interval when you're dealing with match pairs, right? And this is match pairs because it's the same individual with two measurements taken, right? I'm the same person. I measured with my with my right hand, my dominant hand, as it turns out. Right hand is my dominant. The left hand is my non-dominant. But that, obviously, if you're lefty, it would be the other way around. If you're ambidextrous, that muddies the waters even more. But I'm going to create a column that represents my differences. So A4 minus B4. And go down the line. What this tells me, when I did my first trial, you saw one trial with the right hand. So it took a little while to collect all this data. But for my right hand, I had 6 more successful clicks than with my left hand on that first trial. 6 more for the second trial, 3 more, 7 more. By doing it over and over again, I'm getting rid of any kind of weird extreme values, because we'll just kind of pare this down to the middle. But you'll see. I mean, you had some cases where I've sort of ran out of steam. But there's also a learning curve involved, because sometimes you develop a habit, and over time you improve, right? So in this case, my non-dominant ended up starting to kind of catch up and surpass my dominant. Okay? The sample mean difference, what I mean by that is the average of these values, right? So after we've subtracted, so E equals average. Click and drag, lock it in. Then the sample, standard deviation of differences. So standard deviation for the sample. It's not a population. I just did it the 20 some odd trials, and that was it. I didn't do it any more than that. If I kept doing it infinitely, then maybe you get closer to a population value, but for now it's just sample. The mean of the sampling means is the same as the sample mean difference. So you could just do a quick equals this number. The standard error is this number, so equals this number divided by however many values there are here. So the square root of that, I should say. So SQRT. You can count them up, or you could use the count feature. I prefer to use the count feature so I don't have to think. And also, the benefit of doing it that way is if I expand my data, all I have to do is update the row reference. Instead of being 28, it would be down to whatever the new number is. All right, so we'll do the 3 confidence intervals. So I preloaded it in here because this one's a little trickier to remember. So inverse T, so this is a T distribution, two-tailed, using the alpha value 0.01, and using the count values. So the count values go from 4 to 28, so I have to update that. It'll be updated on your end when you see it, but I usually start with some sort of template and I just update the row references to make life easier. All right. So then I can do my low bound. So that's going to be equals the mean of the sample means minus your confidence level multiplied by your standard error. Sorry, not the confidence level. The critical value is what this is called. So this times your standard error. Lock it in. On the high bound, minus goes to plus. I also left this so that you could use the concatenation to come up with your conclusion, a little bit more efficiently. All right. So if you just copy paste this and just update what needs to be updated, these are scores really, so we can do that. You could change it to mean difference in clicks if you want. It's up to you, but I think calling it a score is reasonable. Now this is saying that the difference in score is anywhere between about -2 and about 2.5. So anywhere from a negative number to a positive number, right? If you look at the differences here in the table, if the difference is positive, that means my right hand scored better than my left hand. If the difference was negative, it means that my right hand did not score as well as my left hand. All right, because my bounds allow for anything from a negative number to a positive number, including 0, this ends up being inconclusive. All right, so I can't say that my right hand is any better than my left hand based off of this confidence interval. All right, and I put a little notation here. If the bounds are both negative, that means that my left, I think I put that backwards actually. My right was not as good as my left. A little update there. Right, same idea here, right versus left. So this would be greater. So if both of those bounds are positive, that meant that my right hand was better than my left hand, right? So if both bounds ended up being positive, that meant that on average, I'm looking at a difference that is positive, and that's the instance where right outperformed left, right? And this one I guess I don't have to change, but I'll do it anyway. Now, a little note on this one here. This is saying that there's no significant difference. I'm going to throw a comment in there. Means no significant difference. It doesn't mean what it actually says here. It looks like it's precisely the case that right is equal to left. What we're really saying is that we don't have enough evidence to say that right isn't equal to left. Right? So we're kind of looking at the opposite. The burden of proof is on the greater than or less than. If the bounds involve a negative and a positive, then it's inconclusive because we don't have enough evidence to say that my performance for right and left were significantly different, right, on a statistical level. Right? That's for a 90% confidence interval. If we get the same outcome for all 3 types of confidence intervals, then we can reasonably conclude that there's no significant difference. But it could also be the case that for some situations we conclude no significant difference. In other cases, we conclude that there is a significant difference. All right, quick edit here, which I thought I already fixed, but I guess I didn't. So 95% confidence, 0.05. So I want a 0.05 in here. Update my row references to go to C4 to C28. So now I have the correct critical value. I'm going to steal this. Right now, my G5 and G6, those are gonna get locked in. We're not changing those. Right. The only thing that's going to change is my F9, which originally was referencing this cell, would now become F21. All right. So I'll put that in here. Make this an F21. Lock it in. Negative low bound. change minus to a plus, positive upper bound, negative to positive, really the same conclusion, right? So I'm looking at a negative low to a positive high. I can't move off of this idea that there's no difference between left and right, right? Then same idea for 99% and same idea with the typos. All right, so this is a 0.01 now. Again, C4 to C28. All right, get this. My reference goes from F21 to now it's F33. Negative low bound. Minus goes to a plus. Negative low bound, positive high bound, right? So again, no significant difference, and I meant to put a conclusion statement in here. Conclusion. There is no significant difference between left and right hand performance. Put that in yellow, and I'll update the assignments, making sure that that's there, because we do want a final conclusion, right? And the idea is that we're choosing in each case the equals, right and left, no difference, right? And that might have something to do with the learning curve, right? So I was better initially with my right, and then it kind of leveled off, and then I got better with my left, right? So kind of sort of plateaued with my right, even a little bit of a dip off, a little fatigue involved. I did this experiment yesterday, so what I was feeling at the time is still kind of fresh in my mind. I remember running out of steam with my right hand, but then on my left hand, I felt like I was getting a little bit more accurate, right? So I'm looking at this and saying, okay, in the long run, there's really, for an experiment like this, there's no significant difference. Now, that might not be the case for you, right? It might be the case, like if I didn't know the individual doing the study and I was looking at this conclusion, I might say the individual is ambidextrous, right? It's possible that there really is no difference between tactile dexterity with the left and the right hand, like a surgeon, for example, right? But if it turned out that right was less than left across the board, I might say, well, I think this person is a lefty, right? Because they're consistently perform better with their left hand. Same idea if it's consistently better with the right hand. So doing a study like this, if you think back, like when you were younger, like how did you know you were a lefty or a righty? You just knew, right? I know, for example, with hockey, they're like, all right, are you a lefty stick or a righty stick? What they do is they drop a stick on the floor and they tell you to go down and pick it up. And whatever hand you pick it up with, that's your dominant hand. That's what they use to study that. But you could do something involving a study like this to see if a person's lefty or righty, and draw some meaningful conclusions with that. Right? So it's kind of interesting in that regard. Right? The first assignment is really just a practice case of what we just did. Right? And like I said, I got to clean this up, but I'll get that conclusion in there. All right. So this time it's not lefty and righty, so I'll update all this too. And then I have another assignment where you actually collect your own data. So if you click on it, brings you to the link, and you can see here reaction time, click to start. These are the values that we're going to record. All right. We need, I believe, 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 20 of them. That's about half for your left and for your right. So it's going to take a little while, right? So click to start. It'll turn green at one point, and you just click as soon as it turns green. All right. Wait. Do it again. Click when it turns green. All right. Wait. Click to continue. So you'll get 5 values every go, really, and it'll record them as you go. So I'm doing all this with my right hand. All right. When it turns green, I click on it, boom. Do it again, click on the green light. And then I would copy all these values over into my spreadsheet, right? And then I would do it with my left hand, right? So start over. I'm doing it with my left hand. This is definitely less comfortable. All right. Click on the green light. Right, and so on. Right, you get the idea. So you're going to collect all that information. So basically, you got to play this game. There's five outcomes that you can get here. So you play it 4 times right hand, 4 times left hand. You can alternate if you want, do some left, some right, and then go from there.